Hey everyone.
Hey, UG, how's it going?
Hey Mauro. Going good. Happy New Year.
Happy New Year to you too.
Hello.
Hey,
Hey folks, are we waiting for a lead for the meeting? Hey, good morning. Do we have a lead for the meeting today? Anyone know?
No idea. First time I joined. I don't know how you guys usually run this.
I think usually I've seen Paco joining the call,
yeah,
and the leads are Paco, Daniel, and Terry, but I don't see anyone on the call yet.
Yeah, okay. So we're waiting for leads to join. Yeah, this is my first time joining too. Just wanted to participate in the group a little bit.
Yeah, me as well. And there are three presentations I see planned. So Kubelasti, K0S project, and build factorization
Yeah,
application Hadron. So I guess the presenter should be around. I know Hadron, we are here, Mauro and me, but for the others, I don't know.
oh, do
So
we
for the
have
cube
presenters from
velocity,
those?
yes, for the cube velocity, I'm here. One of my Raman is someone I'm waiting for. He will also join. Yeah, yeah, I'll be here. Yeah, for cube velocity, we are there.
Well, it is 5 minutes. Should we run it ourselves?
I guess we can.
I think we can, but I think a few presentations are around, applications, incubation applications, or perhaps the sandbox applications. So even if we run it ourselves, is it through the recording that we get recommendations from the leads?
yeah, I guess in that case would be ideal that the lead is here, right? Because then you would get immediate feedback. Good question.
Work if people are around.
Well, it's definitely
Yeah, but we're
recorded.
6 minutes in. Yeah, we're 6 minutes in anyway, so we can start with what we can start. I mean, the first recording is not about incubation or anything, right? It's just a presentation, and we can decide what we do with the others when we're done with the first one. How does that sound?
Yeah, I'll say I do some of the project reviews, and having the presentation, to review is really helpful. So even if the leads aren't here, it'll come in handy. +1. Let's get started.
All right. So we're waiting for one more person for Cuba last presentation.
Yes, just give us 1 more minute. If there's another
All right.
agenda that we can pick up before that, that'd be helpful.
I guess in the meantime, I'm the one that put the build packs thing on there, so I can just. I thought that something I'm still trying to figure out with the tag reboot is what the tags relationship is to project reviews. But build packs, I guess, could potentially be part of Workloads Foundation. One of the things that a build pack does is it installs a runtime. Like if you're running Node.js or Python apps or Ruby or something, so it does install the runtime into the container, in addition to doing the build of the compilation. If it's being compiled to native or whatever transpilation. So I just wanted to update the group that it's one of the first technical reviews that's being done under this new setup with the tags. We do have a couple people working on it, but yeah, I just wanted to let this tag know that, to the degree that you want to be involved with projects, that's one of the ones that we're taking a look at. So that's it. That's why I put it on the agenda.
Nice. And how do you determine on which of the tags it falls? Is that already pre-selected or?
No, that's exactly what is not so clear. It doesn't necessarily map one-to-one to a tag, and in fact, I saw the developer experience folks might think that it goes in their tag too, and maybe it does. It kind of overlaps because it is part of that build process, which a developer would care about, I guess. So it's not exact. I was just thinking it might be.
Yeah, thanks for sharing. I have also the same confusion at the moment of where exactly different projects should be discussed. Yeah.
Hey, hi everyone.
Hello.
Hey, so I am with Shubham here, for
Hey.
Cubelasty. Yeah, and I think we can go ahead. Yeah. Oh, sorry, I was a few minutes late. Just share my screen. Right. Right. Uh, can everyone see my screen and hear me right? Just checking.
Yes.
Yeah.
All
good.
By the way, before you start, is anybody taking notes? I see we have the agenda document. Are we supposed to take notes by hand, or do we have AI doing that? Just asking now that we are starting. Does anybody know from previous times?
If you have something to add it directly to the notes. AI theoretically works in the Zoom, but I don't know if it saves the result somewhere or not.
Mhm. Okay, thanks. Go ahead. Let's start.
Sure. First of all, thank you so much for the opportunity to present here. Yeah. Um, yeah. So I am here with my friend Shubham. We have known each other for a few years. Have worked on few projects here and there, and this is one of the projects we worked on together. He's a platform engineer at True Foundry, and I run my own consultation firm called Zurich Lab. Uh, I wish I had more interesting things to tell here, but yeah, that's pretty much it about us. Very quickly, so we will go through the story basically that why did we build this project Qvelocity? What are some of the concepts in it, and a 2-minute demo in the end. So I'm sure that most of you must have also seen this before, where there is a huge delta between the allocatable resources and the actual use resources, and this was one of the problem we individually faced, Shubham and I. For example, in this case, you can see the actual usage is about 1 to 2% of the total locatable resources, uh, and that's what we wanted to fix. We set out the requirements, what we wanted from our tool to fix this. We wanted it to work in the Kubernetes ecosystem, first of all. That was very important. We wanted a tool which does not add any latency or does not add itself to the active path when traffic is coming up. And we wanted it to be cloud provider, like agnostic of cloud providers. I think that's given if we are working on Kubernetes with Kubernetes ecosystem. And we also wanted it to work with different gateways as well. So this is what we wanted from the tool. We looked for the existing solutions. While they're great, this is in order from where we tried it. We started with OpenPass actually first, but it required us to rewrite most of our services as functions. While this would have been great if you were just starting, but for us we could not do that. Then we tried Knative. I think this is also something we liked, but it required our services to be deployed as Knative services. We also found it to be like having a steep learning curve. And then we went to Keda, which is again a great project. Uh, However, this did not meet one of our requirements where it did not remove itself from the path, uh, which was important to us. So finally, after like trying all the tools, we thought like, okay, let's try to solve it ourselves. So introducing Kubelocity, something we have built over last year. It is basically a serverless tool for Kubernetes where you don't have to do any rewrites of your existing services. It works with your current setup. It integrates well with HPA or KEDA for when you're scaling. There's no vendor lock-in, so essentially because there is nothing you're rewriting or there is nothing you're changing in your existing setup, so moving away from it or moving towards it is pretty easy. Uh, it uses a smart proxy, which kind of removes itself from the path when traffic hits, and obviously it's open source. We love that. Uh, Conceptually, this is how it looks. I think if there are no pods, your service, if any request comes in, will fail. With Kubelocity, if there are no pods, it uses a proxy to queue those requests, and in the background, it scales that deployment. And then once it has been scaled and is healthy, we send the request and resolve all the requests. That's pretty much the value add there. A little deeper in the concept and how it works. So inside the two components, one is resolver, which is responsible for handling all the traffic, and then you have controller, which is responsible for scaling your services up and identifying if a service has been inactive or basically has not received any traffic for a while to scale it down. Yeah, there are two modes actually. One is serve mode and proxy mode. Serve mode is when the service is up and healthy and receiving traffic. Proxy mode is when service did not receive any traffic, so we scale it down. So we switch to proxy mode where things flow through the Elastic components. Uh, in the serve mode, I think it's the current flow of how like your existing setup might work, where your pods are up and everything is working fine. Uh, in background, Elastic controller is going to Prometheus for every n seconds actually can be configured, and then checking if this particular service has not received any traffic for and like X period of time. In that case, it just scales it down to zero. So yeah, it just scales it down to zero. And then proxy mode is enabled. In proxy mode, every request goes to Elastic Resolver first. Elastic Resolver lets the controller know that, okay, I'm receiving traffic for this particular service, so maybe you should go back and scale it up. In the meantime, I will just hold on all the requests, and that's what it does. And yeah, once the pod is up, it again goes back to the serve mode. So it's a play of these two modes. To tell you a use case where it makes sense, for us, it made a lot of sense in the testing environment specifically. So take this use case where, let's say, with each PR, if let's say you have a front-end service and you have different PRs and you have different previews of those PRs or those changes created for it. And let's say you are receiving no traffic on it, but your services or your pods will still be up consuming resources. Even if, let's say, a single PR preview receives traffic, other two PRs previews which are not receiving traffic will still be up, driving up your cost significantly. With Kubelasty, that need of keeping the pods up all the time goes away. So there are no resources you're consuming there. The moment a request comes in for a particular preview, it automatically scales those particular paths up, and that's how it works. So this was the scenario which, just to tell you the impact of it. Uh, like I've been using it with my clients, and Rue Foundry being a platform as a service company, they already use it for saving a lot of cost for their clients. But with this example, what we saw, we had one front-end service. Let's assume there were 20 PRs open, let's say only two PRs are actively being reviewed at any given point. Uh, in that case, if let's say we take like these particular requirements from each pod, that brings the cost for per pod or per server per deployment to 17.5 USD per month. Uh, and let's say because we only have two PRs getting worked on at each point, everything else that is still consuming resources is essentially a waste and can be saved. So that's a measurable impact we have there in terms of money. Uh, okay, so this is interesting part. Going little more deeper, like how do we achieve this? So there is this Elasticsearch CRD, and this is an example of that a custom resource where we take three major things. One is the service which we want to watch for the deployment, and and the Prometheus query we want to use to see the traffic on a particular or on that particular deployment service. So yeah, I will start this demo video. It's 2 minutes. Let me know if you can't hear the audio from it.
No audio.
Hey, I can't get the audio. Okay, that was unexpected. Uh, does anybody know how to get the audio also?
Are you sharing your screen? Because I see. No, maybe there's a share video or something. I only see share screen
Uh,
though.
okay, there's an option to share sound as well. I should enable that. Uh, uh,
I don't see here.
can we hear it now?
It's
It's
paused.
paused, right?
Now?
No.
Oh, that's
No.
Oh, maybe Raman just narrate over it. This is you. Okay.
yeah,
If
sure.
that would make sense. Yeah.
Yeah, sure. So we basically are starting with we'll just do a full screen. You can hear me, right?
Yeah.
Yes,
Yeah.
yes.
Awesome, awesome. So yeah, here we are basically starting with a demo Kubernetes cluster. It's locally deployed in kind, and what we have is like a target or a demo service, which is basically a HTTP bin service. Just a demo target, and then we have Prometheus installed in it, and then we are using Istio gateway in this case. And this is where we are installing the Helm chart for Elasti. It's provisioning the deployments right now. And I'm just following the guide here, the documentation to do it. So once you have installed it, the second thing you want to do is identify the service you want to make serverless and create a custom resource for that. I'll just expedite it. Okay, I jumped. Uh, right. So we're just creating that custom resource here. Let's move forward a little. So yeah, I'm just explaining that the custom resource which I've created for this particular target. And as you can see that right now it is scaled to 0. Yeah. And I guess I will be sending some traffic to it later. Uh, yeah, now I've applied that custom resource, which means that any traffic I send to HTTP bin should ideally first scale it to minimum 5 replicas, because in my CR I defined 5 replicas. Uh, correct. Yeah, so this is where I'm sending the traffic to that. And in the initial request is a little slow because the services, the pods are still coming up. But yeah, it just works after that. So that was a very quick demo. I wish the sound had worked, but it's fine. Coming to the limitations part of it. So we are actively working on it, trying to overcome the limitation, at least be end to end in this particular area. But as I mentioned, that the first request takes some time, and if your workload is something which uses or like GPUs, or let's say waits for a certain database connection and takes time, that might be not the ideal time to use this. uh, then the second is that if let's say there's a busty traffic at the start when it comes, like initially the first request itself, like after first request it start to go to the peak immediately after that, like the number of requests, then that is also something which might be a little slow for you. And we are trying to expand the support for other load balancers from the different cloud providers as well. uh, fourth thing, which is also something which we are working on, is that right now, because your service is scaled to zero, but your health checks would fail because of that. So we are right now working on this idea to add proxy in our resolver, last resolver itself. So these are some limitations and some work in progress, and we are excited to basically hear more limitations you might think it has, and work on them as well. That's pretty much it. There's nothing else. But if you want to stay connected, if there are any critical feedbacks or uh, anything else, any advice, all of them are welcome. Once again, thank you so much for the opportunity to present here. And you guys are awesome. Yeah, that's it.
Thanks, Raman. Thanks for the presentation. Really nice. Can we ask questions now, or should we do it offline? I just have a couple of them.
Sure. Anything works. Any questions?
Yeah.
Something.
So two things. I'm not suggesting it's similar, but I know there are auto scaling features in Kubernetes. I actually have a link here. Maybe I should send it just in case. I'm wondering. I know there are custom metrics you can use to auto scale pods. So my question is whether you have checked that, and if this is something. I mean, your use case is something not covered by this. Maybe why? Uh, so that's one question. And the other would be, I'm not very familiar with all the managed services, Kubernetes services, but from what I have seen, usually what you pay for is nodes. So you scale up nodes and you pay for the machines. But you're scaling up and down pods. That means your node is still there and you're still paying for it. So I didn't understand how you reduce your spending by that if you're still paying for your nodes.
Correct. Sure. I will take your first question first. I think it was around scaling based on the custom metrics, something like which Kira can also do. So we want to work with certain tools or integrate well with certain tools, and not and that is one of the philosophy we have been sticking with, to work with existing solutions and tools. So we work with that. So that is something we're compatible with. I hope that that's what you were trying to understand. And if you feel that
So I
there
think,
is,
yeah,
sure,
I can
Shubham, if you
maybe
want
add
to add to
something
it.
there. So I think
Mhm.
another part of the question was when Kubernetes already provides auto scaling, what is the use of this particular tool? So uh, getting metrics for auto scaling and then reacting to it is one thing, but in this case, the problem is not dropping any requests at all after having scaled it down to zero, and then when traffic comes in. So that's why a proxy has to be injected in between in the traffic flow. And that's why like we need, so any autoscaler can work on top of Kubernetes metrics or even like Prometheus metrics, but you need this additional component for zero downtime effectively.
Because you scale down to zero. With autoscaler, if you didn't want to miss any request, you would never scale to zero.
Exactly.
That's what you mean. Yeah, okay, gotcha.
Yes.
Okay.
So a lot of services are basically kept up in case someone calls it.
Okay, makes sense.
And Raman, if I can take the second question as well.
Yeah, sure.
Yeah. Can you scroll to the limitations part?
Yeah.
So you're actually correct that if the infra itself is not flexible, then we are not going to see any cost savings. So that's actually the last point. So what we have seen is that in case of on-prem Kubernetes clusters, there's actually, if infra is not auto-provisioned, it's not going to actually do anything because your nodes will just sit there. But in case of cloud, like let's say AWS with Carpenter or GCP with a node auto-provisioner, you do get that. Like the nodes go away and then they come back up. They do add to
Yeah, okay.
somewhat to cold start time, but yeah, that actually does save quite a bit.
Nice. Okay, gotcha. I didn't know they do that.
Yeah.
Thanks.
Okay.
I have a question. What's your like? So I guess it depends on Prometheus. And are these the metrics that it's reading from Prometheus, a standard set of metrics around request to a service? Is that something that comes from cube state metrics or something? Like, where are you getting the metrics from, and what's your dependency on Prometheus?
Right. So the dependency on Prometheus. So we actually depend on metrics from Prometheus. So Prometheus is where we consume it from, but something has to push those metrics to Prometheus. So that's
Yeah.
actually any service mesh or ingress provider, or like your Nginx ingress controller. So there has to be a component in between which can be scraped by Prometheus to get those metrics. So yeah, but I mean, we assume that those metrics are already available in Prometheus. Uh, we have documentation around how to use it with Nginx and Istio. But yeah, what we rely on is like we need to get that data from somewhere. So that is Prometheus right now.
Okay, thanks. Got it.
Yeah.
Yeah, I mean, in future we do plan to like not just support Prometheus but other metrics providers as well.
Yes.
Like yeah, that is something
Right.
in the expansion side.
So just to add some color to that, there is one requirement around AWS application load balancers. So they push their metrics to CloudWatch, and you won't get that in cluster local Prometheus. So we are planning to add that CloudWatch. Yeah.
Do I understand correctly what this HTTP traffic proxying, it works only for unencrypted endpoints, right? So no TLS support.
You mean
So
HTTPS?
Yes.
Right. So it does work with HTTPS,
yeah.
but other other protocols are not supported right now. So if you have a WebSocket or gRPC or uh, yeah, other protocols are not supported right now. That is also in the expansion plan, and hopefully we will start to support other proxies as people come with requests for them. But HTTP and HTTPS being the most popular one, we just started with that.
And how do you handle the certificates for HTTPS?
I believe that it's handled on in the ingress level, right?
I don't think like we are supporting it, to be honest. And the traffic really doesn't matter. I think we should be able to add support to it. But yeah, we'll have to see actually. I don't think we have explicitly added support for it.
I
Okay.
think
But if I understand correctly, you're not really intercepting the traffic, right?
Mhm.
You're just monitoring it. So you only care if there is a request and where
Yes.
it's targeted. So if I understand
I
correctly,
mean,
you don't even care what the workload is. You don't care what the headers are. You just want to see something is coming for that service. I'm going to scale it up and down. So if I
yes, the
understand correctly,
metrics
you
does not
shouldn't. Yeah.
matter. The proxy has to like have traffic flow through it. And I think what Alexander is pointing out is that in case of MTLS or something, like there will have to be a TLS negotiation from resolver to the target service and so on.
Yes, so in case if the service is scaled down to 0, so the first request is intercepted by the proxy, and the proxy, in
Right.
case of encrypted traffic, should respond with a proper TLS certificate.
Yes. So we just like in our case, what we have been doing is just everything is unencrypted within the cluster once it has hit the external, like the edge load balancer. In case of MTLS, yes, I think that could be a good use case, like where you have traffic flowing, TLS encrypted traffic flowing between services within the cluster.
Okay, yeah, thanks. That was the root cause of my question.
Yeah.
So just a quick time check. We're running a bit over the halfway point here. So I think maybe we can move on to the next one, but thank you very much for your presentation. I guess anyone else further questions, please reach out to the project, Cubelasti folks. And I think the agenda is super packed. I'm not sure we're actually going to get to all of them. So I don't know if we should just go in order, if that makes sense to folks that are in the agenda, and we can move on to the chaos project, and folks, things we don't get to, we can add to the next agenda, if that makes sense.
Makes sense.
Folks okay with that? Okay, cool. Thank you. So I guess over to you, Jesse, maybe? Jesse?
Yeah, sure. Hey,
Cool.
give me a sec to figure out how to share my screen. Why do they always put it in different places in different tools?
Definitely.
There should be one standard button to share your screen.
No.
Let's try it this way. Can you see my slides?
Yep.
Yeah. All right. So just wanted to share some updates on the K0 project. It's been a while since we had these presentations on the tag workloads. I believe it was called something different back then, but we're now in tag workloads. So yeah. Just a couple slides what K0s is. We try to be as frictionless as possible. I mean, it's still Kubernetes, so there's always going to be some level of friction which we can't take away. You know that. Our take on that is that we built everything in a single static binary, which means that there's practically no dependencies whatsoever. I mean, yeah, of course, you have to have a modern enough kernel on your operating system that supports all the kernel namespaces, networking stuff, all that usual things that you need with Kubernetes. But apart from that, there's basically zero dependencies, and it pretty much runs anywhere. By anywhere, I really mean like from your Raspberry Pi sized devices to industrial PLC controllers to your typical VMs in your cloud provider and so on. So basically, we can cover the full range with the same single binary. Everything is included in the binary Kubernetes, all the Kubernetes components, container runtimes, all the dependencies, even IP tables is packed with the same binary. And like mentioned, you really can drop the same exact binary file to your various different setups, and it just works. One of the architectural differences that we took from day one was that we wanted to really separate the control plane from the worker plane. What I mean by separating stuff is that there's actually a separation between those. So by default, when you run K0's controller node, you don't actually get kubelet running even. You don't get containerd running. So it's a pure controller. Kube API server schedulers, controller managers, the usual controller and control plane components. What that means is that you can actually now run control plane. I'm going to give you a bad example, but just to illustrate the point, you can actually run the control plane, say in a VM on a public cloud, expose the API server port, which you probably shouldn't be doing in the first place, but let's assume that it's a good idea. And now I can actually connect my worker nodes from my private data center or from my laptop as a VMs or whatever, behind layers of firewalls and nets and whatnot. So the worker nodes are pure worker nodes. So we can really separate the controllers and workers from networking point of view. They can be in very different network segments as long as the worker node can call home to the controller, everything just works. And we use this connectivity server. That's what's the actual repo name? It's one of the Kubernetes 6, the API server network proxy. I think it's the actual repo name for that. But we always always said it's connectivity. So what the connectivity agent basically does, it actually the agent opens up a connection into the controller node, and then when the control plane needs to go to the worker node, like kubectl exec, logs, port forwards, whatnot, it actually goes through this kind of reverse tunnel in a way. So think of it as like SSH reverse tunnels, which probably all of you have been using. It's conceptually exactly the same, although not implemented on top of SSH, but it's a gRPC TLS tunnel basically. So what that really gives us is a lot of versatility in our deployment architectures. Think about like edge-like scenarios where you have super small devices running where you want to run your workloads on the very edge of the network. You probably have a lot of troubles trying to figure out how to run control plane on that specific environment. But now we can actually separate the control plane, run it in some environment where we have probably a lot more resources and things to play with. So gives a lot of versatility on the deployment models. It's just being one of the good examples that I always use in this case, or industrial IoT like solutions. The latest minor release 134, and as obvious, we follow the Kubernetes upstream versioning scheme. So the K0 is 134 in October 25. We added support or rewrote the support for Windows workers following the exact same pattern. So you actually get a single exe file, you drop it in your Windows server, and voila, you have a Windows worker node, which is pretty cool actually, and gave us some gray hair. Well, I don't have hair anymore, but we also added support for IPv6 only clusters, both with Calico and kube-router as the CNI. And then, of course, as usual, there's a ton of minor fixes and some smaller enhancements. And now, since upstream Kubernetes released 135, like in mid-December, we're now working towards supporting 135 in K0's side, and our target for that is late January, early February. So we're usually, for minor releases, we're usually like a month behind. So we joined the CNCF sandbox in February last year, and now we're hoping to get to the incubation phase. So we have the application already submitted. There's a growing contribution base happening. Just as an example, 134 release had 16 different contributors contributing to that specific release. And I think we're hovering around that like 15, 20 contributors per release kind of level. Since the sandbox, there's been some new community collaborations with other projects, including the Kairos folks, which are also in this call. We have the Cordant people building on top of K0s and Cosmotron projects. There's some collaboration with OpenEBS and with some other stuff too going on. We've been focusing on fine-tuning the governance model and security model, and we've been seeing basically steady growth on the community side of things too. So there's almost 300 members in the K0's users and dev channels in Kubernetes Slack, and there's some good active discussions going on, which is super nice to see, of course. We've been sharing lightning talks. We had a Contrib Fest session and the project booth at KubeCon Atlanta. And I have to say the project booth was super fantastic. There was a lot of people there, and will be also in Amsterdam. Also wanted to mention that we, since the sandbox, we started steady-ish bi-weekly community calls. We do it in a bi-weekly manner where one of the calls is for US time zones and the other one is for European time zones. So basically each time zone area gets like one call a month. We also have bi-weekly maintainer calls. What else? We have 9 active maintainers from 2 different companies currently, hoping